Imagine boarding a modern Boeing 787 Dreamliner in 2025. You settle into your seat expecting the latest technology to get you to your destination faster than ever. But here is something the airlines do not want you to know. That same route your parents flew in the 1990s on an older 747 actually took less time. Modern aircraft are deliberately flying slower, and the reason why will change everything you thought you knew about aviation progress. Welcome to Sky Secrets, where we uncover the truths hiding in plain sight at 30,000 feet. Today we are exposing one of the biggest contradictions in modern aviation. Every year, Boeing and Airbus release new aircraft models boasting cutting-edge technology. Yet these engineering marvels are cruising at speeds slower than planes built decades ago. This is not a design flaw. This is not an accident. This is a calculated decision. I have spent years analyzing flight data, airline operational reports, and interviews with aerospace engineers. The numbers do not lie. A transatlantic flight from New York to London that took 6.5 hours in 1995 now averages 7 hours and 15 minutes on newer aircraft. The Boeing 787, despite being 30% more fuel efficient than older models, cruises at Mach 0.85 compared to the 747 original cruise speed of Mach 0.92. Let me start with a fact that will blow your mind. In 1973, a Boeing 747 could fly from London to New York in 5 hours and 54 minutes. That is not a typo. 5 hours and 54 minutes. Fast forward to today, and that same route on a brand new Airbus A350 or Boeing 787 takes an average of 7 hours and 30 minutes. We are talking about aircraft that cost $400 million each, packed with composite materials, advanced avionics, and engines that produce 70,000 pounds of thrust. Yet they are slower than planes designed when Richard Nixon was President of the United States. How is this possible? The answer lies in something called cost index, and it is one of the most carefully guarded secrets in the airline industry. But before we dive into that, let me show you just how dramatic this slowdown has been across the entire industry. The Boeing 707, introduced in 1958, cruised at Mach 0.84. The Boeing 747 Classic from the 1970s pushed that to Mach 0.92. The Concorde, which stopped flying in 2003, reached Mach 2.04. But here's where it gets interesting. Modern jets have actually regressed in cruise speed. The Airbus A380, the largest passenger aircraft ever built, cruises at Mach 0.85. The Boeing 777, one of the most popular long-haul aircraft, operates at Mach 0.84. The newest Boeing 787 Dreamliner? Mach 0.85. We have not just stalled in speed development, we have actively gone backward. And this is not because the technology does not exist. Every single one of these modern aircraft has engines powerful enough to fly faster. The General Electric GE90 engine on the 777 produces 115,000 pounds of thrust, making it the most powerful jet engine ever built for commercial aviation. The Rolls-Royce Trent XWB on the Airbus A350 generates 97,000 pounds of thrust. These are absolute monsters of engineering. So why are they flying slower than engines from 40 years ago? Here is the brutal truth. Speed is expensive, incredibly expensive. And airlines have done the math down to the last penny. Let me break down exactly how this works, because once you understand the economics, everything makes sense. Jet fuel consumption follows an exponential curve, not a linear one. This is critical to understand. If you increase speed by 10%, fuel consumption does not increase by 10%. It increases by approximately 25%. Every additional Mach 0.01 costs airlines roughly 1% more in fuel. That might sound small, but let me put it in perspective. A typical Boeing 777 flying from Los Angeles to Singapore carries around 180,000 liters of fuel. At current jet fuel prices, that is roughly $140,000 worth of fuel for a single flight. If that aircraft increases its cruise speed from Mach 0.84 to Mach 0.9, fuel consumption jumps by approximately 15%. That single speed increase adds $21,000 to the fuel bill for one flight. Now multiply that by the fact that a large airline operates hundreds of long-haul flights every single day. We are talking about tens of millions of dollars in additional costs every month. For what benefit? Arriving 30 minutes earlier? Airlines have calculated that passengers are not willing to pay enough extra for that 30 minutes to justify the fuel cost. And they are right. This brings us to the most important concept in modern airline operations: cost index. Every commercial aircraft has a flight management computer that calculates the optimal speed for each flight based on a single number entered by the pilots before takeoff. This number is the cost index. Cost index is essentially a ratio that compares the cost of time versus the cost of fuel. A cost index of 0 means fuel is infinitely expensive compared to time, so the aircraft will fly at the slowest possible speed to minimize fuel burn. A cost index of 100 or more means time is extremely valuable, so the aircraft will fly near its maximum speed regardless of fuel consumption. Back in the 1990s, when fuel was cheap, airlines would routinely use cost index values between 80 and 100. Aircraft would cruise near their maximum speeds, flight times were shorter, but fuel prices have increased dramatically since then. In 1990, jet fuel cost around 20 cents per liter. Today it averages around 80 cents per liter, a 400% increase adjusted for inflation. As fuel prices climbed, airlines steadily lowered their cost index values. Today, most major carriers use cost index values between 20 and 40 for long-haul flights. Some ultra-low-cost carriers use cost index values as low as 10. The result? Modern aircraft fly 15 to 20% slower than their maximum capable speeds, even though they have the power to go faster. So, what does this mean for you as a passenger? First, and most obviously, your flights take longer. A route that used to take 8 hours now takes 9. A flight that was 11 hours is now 12 and a half. Airlines rarely advertise this. They quietly adjust their published schedules and hope passengers do not notice. But there is something even more insidious happening. By flying slower, airlines can operate the same routes with fewer aircraft. Let me explain. If a round-trip flight from London to Singapore used to take 30 hours total, including turnaround time, an airline needed enough planes to maintain their schedule. But if you add 2 hours to each direction by flying slower, suddenly that same round trip takes 34 hours. The airline can reduce frequency or use the same number of planes to fly fewer routes, cutting their overall capacity costs. This is why you have probably noticed that many international routes have fewer daily departure options than they did 10 or 15 years ago. It is not just about demand. It is about airlines deliberately slowing down operations to maximize the efficiency of their expensive aircraft assets. Now here is where things get really interesting. Airlines love to talk about how modern aircraft are 30 to 40% more fuel efficient than older models. And technically, that is true. The Boeing 787 burns 30% less fuel per passenger kilometer than the 767 it replaced. The Airbus A350 is 25% more efficient than the A340. But here is what they do not tell you. Much of that efficiency gain comes from flying slower, not from better technology. Yes, composite materials reduce weight. Yes, modern engines have higher bypass ratios and better fuel efficiency. But the single biggest contributor to improved fuel economy is reduced cruise speed. If you took a Boeing 787 and flew it at the same speed as a 1990s-era 747, the fuel efficiency advantage would shrink from 30% to maybe 15%. The rest of the improvement is purely from going slower. So when airlines market themselves as environmentally friendly because of their modern fleets, they are not lying, but they are not telling you the whole truth either. The environmental impact is actually more complex. Flying slower burns less fuel per flight, which reduces carbon emissions per flight. But it also means aircraft spend more time in the air, which increases total atmospheric exposure. And because airlines optimize for profit rather than speed, they are often adding flights to maintain frequency, which negates some of the environmental benefits. If you want to understand why speed died in commercial aviation, look no further than the Concorde. This magnificent aircraft could fly from London to New York in 3.5 hours, cruising at twice the speed of sound. It was an engineering masterpiece. It was also a financial disaster. The Concorde burned approximately 25,000 liters of fuel per hour. A subsonic 747 on the same route burned 11,000 liters per hour. The Concorde carried 100 passengers. The 747 carried 400. Do the math, and the Concorde used more than 9 times as much fuel per passenger. Ticket prices had to be astronomical to cover costs, limiting the market to ultra-wealthy business travelers and celebrities. When the Concorde was retired in 2003, it sent a clear message to the aviation industry. Speed for the sake of speed is not economically viable. Passengers will not pay enough extra for faster flights to justify the fuel costs. And so the entire industry shifted its focus from speed to efficiency. Boeing and Airbus stopped researching supersonic passenger aircraft. Engine manufacturers focused on fuel economy rather than raw power. And flight operations departments at every major airline started programming their cost index values lower and lower. So, will we ever see faster commercial flights again? The short answer is probably not, unless something fundamental changes. There are a few companies working on supersonic business jets for wealthy individuals, but mass-market supersonic travel is not coming back anytime soon. What we are more likely to see is further optimization of subsonic flight. Airbus is developing what they call a blended wing-body aircraft that could be 20% more fuel efficient than current designs. Boeing is researching advanced materials and engine configurations, but none of these innovations are aimed at making flights faster. They are all about making flights cheaper to operate at current speeds. There is one scenario that could change everything: a breakthrough in sustainable aviation fuel or electric propulsion. If aircraft could fly on cheap, abundant, zero-carbon energy sources, the economic equation would flip. Speed would no longer be constrained by fuel costs. We might see a return to Mach 0.9 or even supersonic speeds for certain routes. But with current technology and fuel economics, airlines have made their choice. Slower is more profitable. And unless passengers start demanding faster flights and proving they will pay significantly more for them, airlines have zero incentive to change their strategy. So the next time you board a gleaming new Boeing 787 or Airbus A350, remember this: that aircraft is capable of getting you to your destination 30 to 40 minutes faster than the flight schedule shows. The engines have the power, the aerodynamics are optimized, the technology exists, but the airline has deliberately programmed the flight computer to hold back. They have calculated that your time is worth less than their fuel savings. They have determined that you will accept a longer flight if the ticket price is lower, even if that price reduction is invisible to you. Modern aircraft are not slower because of technological limitations. They are slower because of economic optimization. And as long as fuel remains expensive and passengers remain price-sensitive, this trend will continue. We live in an era where a 50-year-old speed record still stands, not because we cannot break it, but because we have chosen not to. Right now, as you watch this video, airlines are calculating their cost index values for tomorrow's flights. Every major carrier is programming their aircraft to fly slower than necessary. Your next flight will take longer than it should, and most passengers will never know why. This is happening on every route, every day, across every airline. The window to understand this before booking your next trip is closing. The aviation industry profits from passenger ignorance, and they are counting on you to never question why modern technology delivers slower results. If this video opened your eyes to the hidden economics of air travel, smash that like button right now. Subscribe to Sky Secrets and turn on notifications, because we are just getting started exposing what airlines do not want you to know. Every week, we reveal another layer of the aviation industry that affects your wallet, your time, and your travel experience. Drop a comment below telling me which airline secret you want us to investigate next. Your engagement helps us reach more travelers who deserve to know the truth. Do not let the algorithm hide this from other passengers.